right, let's do this. CSE116 summer. Welcome, welcome. Get comfortable here. And let's get started. Suppose I can leave this tab open. I'm gonna want that each day. All right, let's do this. First of all, if there are any tech issues, make sure you let me know. There are some streams where like my audio was all choppy and crappy. No one said anything during lecture, and then after an office hour, somebody told me. Went back and looked at the VOD, and yeah, the whole audio was trash for the entire lecture. So things like that happen. I can fix those things. The quality of everything should be pretty good. So if anything's crappy, let me know. I'll fix it. All right. So first thing, a few things. I said these in my email, but just to make sure we're all on the same page, the course website, literally in this case, course website CSE116.com. I can't make that any easier. If you remember what course you're enrolled in, you can remember that course website. So that one we should be all there, and I assume you all saw this website already anyway. I always forget this part, but my name is Dr. Jesse Hartloff. I like to just go by Jesse. We can keep it casual. And if you have any questions of me, just in the chat or just in office hours, hey Jesse, what's up? Is perfectly fine. If you want more formality, doctor, professor, it's all accurate and whatever. But we can just keep it casual. All right, so let's start just going through things. YouTube, if you haven't found this link yet, I don't know how you found me here, so I don't think I have to talk about this one too much, but I do want to highlight a few things anyway with this one. Is obviously you're here because you're watching the live. But also I have all the past lectures for that I've recorded before. So one, there's all the videos. If you go to the uploaded videos, you can see all the lectures from a regular semester and also some videos that won't be relevant this semester. They're related to different homework assignments. But also all my live lectures. You can go through the entire course the way it's structured in a Monday, Wednesday, Friday 14-week semester with 50-minute lectures. You can check out all those, or probably more preferable for this structure, you can go to my past lectures from last summer or even 2 summers ago if you want to see the older stuff. But you can check out all my streams from last summer. I'm going to go through the same content in the same order. Most of it's going to be the same slides. There'll be small updates I make here and there, but it's all the same content. So if you go to Lecture 1, Intro to Java, this video here is pretty much the same stuff that I'm going to do today. So if you want to get ahead on lectures, or I don't know any other reason you would want to do this, but if you want to get ahead on lectures and take a look at what I'm going to talk about Thursday, what I'm going to do next Tuesday, etc., you can go through all of these lectures, every single lecture right now, and watch the older versions. So if you want to get ahead, there's nothing stopping you right now from watching the whole semester. And you're seeing this right. It is only, if you haven't looked at the schedule and seen how everything's structured yet, there's only 10 lectures of content. 10 lectures. We have 12 on the schedule. It's a Tuesday, Thursday class in 6 weeks. So that's 12 lectures. One of those is a holiday. We have Juneteenth falls on a Thursday. Morning, Dave. And the last lecture is the final exam. The entire lecture is just dedicated to the final exam. And we also have a midterm, so half of that lecture is eaten up by the midterm. So there's really only 9.5 lectures. Now lectures are 2.5 hours long, but there's only 9.5 lectures. So this goes fast. I already gave this warning twice in my intro email, but the summer goes ridiculously fast. I will repeat this a lot. Summer goes ridiculously fast. You cannot fall behind. So I know, like today, looks like a lot of you are in here live, but I know how people roll. Like that's gonna fall off. I like to tell myself that you're just watching the old lectures and just watching them that way and getting ahead. But based on the failure rates, I think a lot of students don't watch the lives and don't watch the VODs and just fall behind. And if you fall even a day behind in the summer, a day, 2 days, if you fall behind 2 days from a Tuesday, you're already a full lecture behind, which is the equivalent of a full week behind in the regular semester. I said this in the intro email, but just to make sure you hear it from my voice, is a great way to fail. If you fall one lecture behind, you're pretty much done. Like you can't get caught back up. In the regular semesters, in the fall and spring semesters, I say it's very difficult to get caught back up if you fall a week behind. It's extremely difficult. You really got to work your ass off to get caught back up. But in the summer, there's just no time to get caught back up. If you fall behind by a lecture, you're pretty much cooked at that point. There's pretty much there's no saving you at that point because you're behind on an assignment, but the next assignment is already almost over by that point, and you're just not gonna get back there. You're not gonna come back. And I say that I don't want to scare anyone. Well, I want to scare you a little bit, just scare you into action. But I say that to make sure that you know what you're in for. If this is 6 weeks of focusing on CSE116 pretty intently. Like this is your full-time job for 6 weeks. So if you have that mindset and you're putting in the time, you're going to do fine. But if you think you're going to enjoy your summer break and just screw around for a few weeks, and then when the course starts ramping up, then get into it, well, the course ramps up today. Like there's no doing that. The course is only 6 weeks, so focus on the course for 6 weeks. Then the next 6 weeks, 6 or 7 weeks, I think it's 7 weeks it ends up being, that's summer break, and that's where you get to fuck around and do whatever you want. AutoLab, if you're not from UB, if you're from UB, you've seen this tons of times. Oh, I'm not even signed in. You know what, it's worth showing you. But I'm going to get duoed. AutoLab, this is where we submit programming assignments. There are 8 programming assignments this semester, and they are all live. They're all ready to go. I have my credit on all of them just to test them all out, make sure they're working. And if you haven't seen AutoLab before, if you're not from UB, this is where we submit programming assignments. You choose your file that you want to submit. Tell me that you didn't cheat. Click submit, and it'll auto-grade your assignment. So when you get your feedback, you'll see something like this. It'll show you all the files that you submitted to make sure your zip file, you can confirm your zip file worked the way it's expected. And then you'll get a variety of feedback on your submissions, on your submission. Once you pass all of the tests and your tests pass all of my tests, stuff we'll get into in the semester, you'll get a 1 saying that you've completed the task. If you don't get a 1 on this, you can resubmit as many times as you want until you do get that 1. So you do get unlimited submissions. You can just keep submitting, get your feedback, submit, get your feedback, submit, get your feedback. I recommend not abusing that system, so you're actually thinking about your code and figuring out how it works. But if there's something you're hung up on and you just can't figure out what the feedback means, you do have unlimited submissions to keep doing that over and over. I always have students, the first time they see AutoLab, they're not, some students aren't aware they have unlimited submissions. They think it's one and done. They submit once, they get a 0 on the assignment, and they say, well, I guess I'm done with the course. I can't pass anymore. That's not the case. You get unlimited submissions, so take advantage of that if you will. Recommended strategies aside, you can take advantage of that. It's allowed, I'll say. GitHub, this is where all the code is going to be. Any code that I show in class is in this repository. If you go to source, you'll see all the breakdown. It's broken down by weeks, the way it flows in the fall and spring semesters. So they'll be a little disjointed, but for the most part, you can just read week as lecture. This is all the lecture 1 content. These are the examples I'm going over today. Week 2 will be all the examples from Thursday, etc. It's roughly going to be lecture for lecture. So you can always follow along with the code that we cover in lecture. I can close these. There's two, I kind of label these confusingly, but there's 2 exams, and each exam has 4 quizzes or 4 traces. I should probably work on the naming convention there. And when you do those quizzes, you're going to use our tracing tool called UB Power, and this is what we're going to use to trace code with memory diagrams. If you took 115 at UB, you know what that's all about. If not, we will get into it. We'll do our first trace today, and I'll go through this and kind of take it from square one. I'll assume that you haven't seen 115, but I will cover the basics very quickly when we get to this. But this is a way to read the code and then show this is Python code, but to read the code and then show me everything that's happening in memory as that code executes. We can add what's happening in the stack, what's happening in the heap, and what's printed to the screen as this code executes, and line for line, just annotating everything to show that you know how to read code and exactly how that code runs in the machine. So if that doesn't make sense to you now, that's fine. We will discuss it at length. And the memory diagram reference. This is, as the name implies, a reference for a lot of the basic operations on the tracing tool, showing you how to do it in the tool. Some sample traces, lots of sample traces to show you just how everything's supposed to work, and covers all the core topics that we'll cover throughout the semester. Piazza. I'm not logged in here either. Is it worth logging in here? Probably. I set it all up on my other machine. This machine I pretty much only use for streaming, which I had to set up yesterday. Well, I didn't have to set it up yesterday. I was acting like a student and doing it the night before. But I did a clean install of Windows and had to reset up everything. But the Piazza is where you can go to ask questions. If you're asking a question that includes some of your code, go to New Post, Post to Instructors, and then that's going to be private, so only myself, and the 2 TAs can see that question. So if you have to post your code, make sure you post private to instructors. If it's something that applies to everybody and doesn't have any sensitive information like your code, because obviously that's an academic integrity concern if you're sharing your code to the whole class. If it's not a concern like that, like these questions that have already been asked, I'm not going to click on them because I don't want to dox anyone. But if it's relevant to everybody, feel free to make it public as well. But to ask questions, if it's not during office hours, if it's during office hours, we have the office hour schedule, or you can post on Piazza during office hours too, I suppose. But the office hour schedule is here. All office hours will be on Zoom in this meeting. You just click on this meeting. It'll add you to the main room of the meeting. The way we're going to do office hours is we'll be in breakout rooms. So if you do go into the meeting, I know I'm just basically reading this note to you, but I just want to make sure everybody hears this because I get this question every summer, is when you go into the main room, you might not see anybody there. If it's during office hours, one will be there. The TAs will update this, or myself, if I have to cancel office hours, will either cross out our name or remove our name from the schedule. So if you're in the meeting and nobody's in there, and you go to the schedule and our name is still on the schedule and not crossed out, we are in office hours, but we're in one of the breakout rooms, so you don't see that we're in there. Unfortunately, Zoom doesn't show you who's in any of the breakout rooms, so there's no way for you to know that we're in a breakout room. But we're in a breakout room, and then we invite you into the breakout room one at a time. So if it looks like you're in the meeting alone, what's usually happening is we're in the breakout room with another student helping that student, and you're in the queue waiting for your turn. And once we're done with that student, we'll kick them out of the breakout room, and we'll invite you into the breakout room. So if you're the only one in the meeting, just be patient, sit around, and we will get to you. You will eventually, it'll say you've been added to a breakout room, and then you'll be able to get your help. The TAs, Matthew and Miriam. Miriam doesn't have her office hours on here yet, but this should be filled out. I asked the TAs to prioritize Wednesday and Friday Matthew obliged. And hopefully we'll get some Merriam office hours in these time slots here. And mine are right after lecture. There's this is the 8 a.m. to 10:30 a.m. lecture. So till 10:30 I'll be doing this lecture, then a half hour where I get to eat some lunch, and then 11 to 1:30 is the other lecture, and then another half hour so I can just breathe and not talk for a second. And then I'll have my office hours right after lecture. So if you have questions right after, well, I guess you have to wait a bit after this lecture, but after I'm done lecturing, then I have my office hours right there. And always be as opposed to any time, any day, any time of day, of course. And then Discord, I won't click on this one, but Discord, I've been using the same Discord since COVID. So there's a lot of students in there, a lot of alumni in there. If you want to go in there and chat with other students, you're more than welcome. I usually use Discord as a form of live chat during live lectures, and then I have Discord on my phone during live lectures. It's not really relevant in the summer because I got YouTube chat right here that we don't really need that during lecture. But you can still use it as a resource to talk to other students. There's a 116 channel. If you ask questions in there, there'll be tons of other students who have taken the class in previous semesters, alumni, everything. It's a very great resource to take advantage of. If you ask a question in any of the channels, there will be a lot of people happy to share any information that they have with you. I want to talk about the difference between the two lectures, but I'll do that when we get to the schedule. So let's just go right into the syllabus. And I'll try not to just read this to you. I'll try to get through this fairly quick. I usually spend a whole lecture just doing this intro to the course stuff, but I want to get to the content a little quicker in the summer, just because the pace is so fast. I want to spend more time on the content. We don't really have 50 minutes to read the syllabus to you. So 116, my tagline for 116 is how to write large pieces of software. To that end, we're learning unit testing, OOP, object-oriented programming, and a few more data structures and algorithms. That's what we'll cover this semester. We want to, with a focus on, morning Carson, with a focus on how to write large programs. So we will see some bigger pieces of code, nothing exceptionally big. It's what we can fit in a semester. And just a very brief, in the spring, we had a pretty substantial project that we're running, and I'll run it again in the fall. I just don't think that fits in a 6-week structure, so the programming assignments are a little bit more condensed. It's still a fairly large piece of code. Coming from 115, it's going to feel pretty large still. Not as big as I want it to be, but 6 weeks, we do what we can. I didn't fix this typo. All right, so expectations of you: invest a minimum of 12 hours per lecture. This is usually per week in the semesters, but each lecture is basically a week. So this should say 9 hours per week per lecture outside of class. So we have 12 hours per lecture is the expectation. That's for taking a 4 credit hour course. That's usually the weekly. 2.5 of that is spent in lecture. I'm rounding up to 3 because I didn't feel like putting 9.5 right here. I'll round that up to 3 for lecture. So you're spending 3 hours in lecture each lecture for each lecture, and then 9 hours outside of lecture, usually working on the programming assignments, but also studying the material, looking over the course slides, preparing for the midterm and final exams, the traces and everything. 9 hours per lecture, so there's a total of 24 hours per week you are expected to invest in 116 at a minimum to be able to do well in the course, to be able to really pass the class. If you're putting in less than 24 hours per week this summer, so times 6, a little shy of 150 hours in the next 6 weeks spending on this course, I would not be surprised if you failed the course. Like, the course is demanding, the course is difficult, and we're crunching it into a 6-week time frame. I know I've said this like 5-6 times already, but it goes fast. You got to keep up. It's a big time investment. I assume you want to learn computer science. I assume you understand the basics of programming, which goes to my asterisk here. This 12 hours per lecture minimum / average. It is an average, which means this week when there's nothing due, it's very tempting to just slack off this week. Well, that 24 hours, you're going to have to make it up, or rather the 24 minus lecture. Hopefully you go to lecture at least. But minus those 5 hours, so 19 hours. That'll catch up next week. So if you don't do anything this week, if you don't start the programming tasks or anything, expect to spend, lots of time in later weeks because that time's going to catch up. Similarly, if you don't know the basics of programming right now, that time's going to catch up to you too. Like if you don't know the basics, if you don't know your 115 basics right now, today, at this moment, you're already behind. You're already putting in more than 24 hours per week. You have to, because you're basically catching up what you didn't learn in 115. And unfortunately, I do see that a lot in 116, students who don't really have a full grasp of loops and data structures. So those 115 topics, variables, functions, data structures, loops, conditionals, your if statements, reading files. We won't do much with that, but there's a little bit of it later in the semester. And I think that's it. Just your core basics. You need to have those down, like solid. You need to be a master with all those things. If you're not, if you're struggling to understand what you did with like lists and dictionaries in Python, you're already playing catch up. So that's hopefully my last warning. I'm sure I'll mention summer goes fast a bunch of times, but that'll be my last. I think you get the point at this time. All right. So the learning objectives of the course are split into OOP and data structures and algorithms. And for each of these, I need you to be able to read and write code that uses both of these. And each one of these is split into 3 topics. OOP is split into classes, inheritance, and polymorphism. So I need you to be able to read, which means using the tracing tool and tracing through a piece of code that uses these 3 topics. So I need you to be able to read code that uses classes, inheritance, polymorphism. And I need to be able to write code that uses classes, inheritance, and polymorphism. Similar to data structures, our topics are linked lists, trees, and graphs. So I need you to read code that uses linked lists and trees, and write code that uses linked lists, trees, and graphs. The only notable omission here is reading. I don't ask you to read code that uses graphs. So there won't be any graphs on any tracing quizzes. And there are reasons for that. We don't have to get into it right now. Morning, Vak. And we don't have to get into why. I just don't think it's an important learning objective to have you trace graphs for reasons. You don't need to hear the whole spiel why I think that. Just know that graphs will never show up on a quiz on the midterm or final exam. But you will have to write code. There is task 8. Programming task 8 is all about graphs. So if you can do all these things, you should pass the class. And if you can't do all of those things, you won't pass the class, which gets us to the grading. Oh, my dog barking. Which gets us to the grading of the course. There are, and this is where my terminology gets kind of awkward. We have quizzes, which are contained on the midterm and final, which contemplating if I should go shut my dog up. Looks like he got over it. So 2 quizzes, which are separated into OOP and data structures, so they correlate directly to the 2 reading portions, or the 2 reading learning objectives. These 2 quizzes are going to be on the midterm and final exam. Do I have to pay for every course which is available on edX? I don't even know what edX is, to be honest. So I don't know how to answer that question. So this course is through, if you're from wherever and you just stumbled upon this stream, this is a course at the UB, the University of Buffalo. I live stream the lectures publicly, so anybody's welcome to just pop in on the lectures. Obviously, you wouldn't have access to all the other course content, like half the links at the top of this page, you won't have access to. But you're welcome to watch lectures anyway. But I don't know what edX is. I don't think that's... maybe that's what UB calls this. I just don't even know. But I don't handle the money side anyway. Even if it was at UB, I don't know how the money side works. We're into scene. Okay, so the quizzes are divided between the midterm and final, and the midterm and the final exam are both going to look pretty much exactly the same in the way that they will both have the same structure. They're both going to have 2 OOP traces, which collectively I call an OOP quiz, and 2 data structures traces, which I collectively call a data structures quiz. In the regular semesters, those are 2 separate quizzes, which is why I kept this terminology of quizzes, even though I combine them into what I'm calling a midterm. But there are 4 traces on the midterm and final exam, 2 OOP and 2 data structures. All traces are graded on a pass-fail basis. They are manually reviewed. The TAs and myself, the way logistically it's looking, it might just be me doing all of the grading and the TAs focusing on office hours and Piazza, so they can get your questions answered, and then I'll spend my time grading. And so it might be me manually reviewing these. And if it's a pass-fail decision, like failing the course, I always manually review those, even if a TA grades them. So my eyes will be on these. You're not gonna fail based on a grading mistake. But they will be manually reviewed, pass-fail basis, for quizzes, for traces. And the way you're graded on these is you have to complete one of those traces to complete the learning objective, the corresponding learning objective. So with OOP on the midterm, you have 2 OOP traces. If you pass one of them, you have completed the read OOP learning objective. And that quiz will have classes, inheritance, and polymorphism on it. So you pass that one trace, we're assessing all 3 of those, the whole learning objective in that one trace, and you're going to get 2 shots at it on each exam. So the midterm, you have 2 of those, pass one of them, you pass the learning objective. Same with data structures, you have 2 data structures traces on the midterm, you pass one of them, you have completed the data structures learning objective. If you don't pass either of them, so maybe you pass like one of the OOPs but neither of the data structures, then you have the final exam as a second chance, or rather a third and fourth chance, to pass these traces. On the final exam, same exact structure, pass at least one of these, then you completed the learning objective. So across all 4 OOP traces and all 4 OOP data structures traces, you need to complete one of each at a minimum to be able to complete the learning objectives. And learning objectives are important because this the course is graded. Again, I won't go into the theory and everything and the reasoning behind this. If you want to know, come ask me in office hours. I'd be happy to talk about it for hours. But the course is based on a mastery-based learning structure, which means you have to complete all of the learning objectives to pass the class. So if you don't complete every learning objective, you haven't learned what you came here to learn. You need to learn all of those things, all the learning objectives, which is true for every course, but a lot of grading structures leave some holes in your knowledge. We don't want any gaps in your knowledge moving forward. So when you go to 220, 250, I want you to actually be prepared for those courses. So you have to know, you have to complete the learning objectives or you fail the class. So if you miss any learning objective, you fail the class. If you complete all the learning objectives, which if you're putting in your time studying for these traces, doing the program assignments, you should, every one of you should be able to accomplish this. Just put in the time, put in the work. And then we'll talk about application objectives after that. So you have to complete one of these OOP traces and one of these data structures traces, or you do fail the course. But for each one across 2 exams, you have 4 opportunities on the midterm and final. So there are plenty of opportunities to be able to pass these. And to be honest, I don't make the traces overly difficult. If you have an understanding of what you're doing, it's hard to fail these on accident if you're well prepared going into these exams. And then the 8 programming tasks. This one's a little more straightforward. You just got to finish them all. In AutoLab, all 8 of them, you need that score of 1. If you don't, you haven't completed the course and you fail the course. So you do need to complete all 8 of the programming tasks. If you complete all those, your grade's going to depend on application objectives. All right, application objectives. So LOs, that's how you pass the class. AOs, application objectives, this is where you're earning your A. You're working towards your A. And you do need to get, first thing I'll point out, you do need to get at least 3 of these to get a passing grade too. So you do need a couple of application objectives, but a lot of these are free, I'll say. I think most of them are free. If you're passing the class, my intent is that if you pass the class, you should get an A. The grading kind of ends up being pass-fail grading. Most students either get an A or an F in the course. You either completed the learning objectives or you didn't, but I feel obligated to give you a letter grade, so there's application objectives. And the application objectives are used to motivate you to, guess what, stay on track with the course, stay up to date with all the content. All these are designed to just get you to stay up to date. So there's 12 total application objectives. 8 of them are just doing the programming assignments on time. So making sure you don't fall behind. So there's 2 deadlines. There are 2 deadlines for each programming task. One, the expected deadline, as the name implies, is the one I expect you to meet, to complete it before this deadline. And this deadline is 2 days, 8 a.m., 2 days after the material for the task was covered in lecture. So you sit down in lecture, you learn the material, you got 2 days, a little less than 48 hours from the start of that lecture to complete that task, which is a tight time frame. This is why I prioritize Wednesday and Friday office hours, because that's when you're expected to be doing the assignments. Then Monday, we have a few Monday office hours, but you really shouldn't be working on anything Monday. So I like to view this course as 4-day weeks. You have Tuesday, you're in lecture, you're thinking about lecture and stuff. Wednesday, and then you're starting the assignment. Wednesday, you're finishing up the programming assignment for that lecture. Thursday, you learn new content in a new lecture. Friday, and starting the next assignment. Friday, you're finishing up that assignment. And then 3 days of not thinking about CSE116 for a moment, getting your breather, enjoying a little bit of your summer. Hopefully there's nice weather and you can go enjoy it. And then Tuesday, start the process over again. So that's how I view the summer. If you have that same attitude, treat it as a Tuesday through Friday, 4-day week, and just put in a ton of time those 4 days. From lecture on Tuesday and Thursday until you're done with the assignment for that lecture, you should just be thinking about 116 during that time. And if you do that, I don't see anybody taking that approach and still failing the course. Especially we'll have tons of office hours during those times where we're expecting you to work on the assignments. Tons of coverage on Piazza. We'll be watching Piazza closely. You should be fine if you're aiming for these expected deadlines. Each time you meet an expected deadline, you get 1 application objective. So if you're just doing what you're expected to do, what you're hesitant to say supposed to do, like you can do whatever you want. But what I'm encouraging you to do, you'll automatically get a B+. Like just doing the assignments on time. Now you have to do the assignments to pass the class. You have to do these anyway. So this is my way of saying, look, if you just watch the lectures the day, like even if you don't watch them live, watch them the day that they were broadcast at the very least, and then the next day spend the whole day working on the assignment till it's done, you'll get a B+. Like I think that's pretty fair. You might argue the deadline's tight, but hey, it's 6 weeks, and I don't have much room to put these deadlines. And the reason it's 2 days is because that's before the next lecture starts. If you're working on the previous assignment, still when the next lecture and the next assignment content starts, That's just hard to do. You have two topics in your mind at the same time. You're not gonna pay much attention to the next content if you're still applying the previous content on the previous assignment. It's just really hard to do that. You're making a difficult course even harder on yourself if you do that. So 2 days, you're finishing an assignment before the content for the next assignment starts. So that previous assignment you can put out of your brain, you'll rest easy knowing that it's done, and then go into the next lecture fresh, ready for the next topic, and ready to start working on the next assignment. So that's why it's 2 days. It's because there's 2 days between Tuesday and Thursday. That's the reason. And each time you do that, there's an application objective. But the grading structure, at least on the surface, I still argue, I'll always argue that the grading structure is fair. Most students don't see it that way, especially on the surface. Like right now, you're probably all screaming, holy shit, that's not fair at all. That is a ridiculous grading structure. And I'll just say, hold off a little bit, live through it for a little bit, and then see how you feel at the end of the semester. I think most students by the end feel that it's fair, unless of course they fail the class. Then they'll always say it's unfair. But it is unfair on the surface, and I have lots of accommodations for that. One of them is the final deadline for each assignment. So I expect you to finish an assignment in 2 days, but if you don't finish it in 2 days, you don't just fail the course. You have the final deadline, which is at midnight, 11 days after the content starts, which I should have tighten this up a little bit. 11 days is way too far. If you're relying on any final deadlines, you might as well just resign the course because you failed already. But just to make sure that I give you the illusion that you still have the option to pass the class, even if you missed an expected deadline, 11 days. Like if you're 2 lectures behind, there's no sugarcoating it. You're gonna fail. Like nobody comes back from that. But I do give you the option, like, if you can prove me wrong and take 11 days to finish an assignment and then meet the final deadline, you can still pass the class. So you will still get the learning objective for that programming task, but you won't get any application objectives for meeting that. So if you're relying on final deadlines, say you met 3 expected deadlines, but then you started relying on the final deadlines and you didn't get any of the AOs from quizzes, you can still squeak by with a C-. I'll still let you can still pass the class, but it's, I think it's unlikely you'll ever pass the class if you're relying on any final deadlines. If you're going all the way to the 11 days. Sometimes, hey, something happens at the deadline, 8 a.m., you just didn't get it done, and you needed 3 or 4 days, you're still going to come back and pass in that situation. But if you're submitting at 11:55, 11 days after the content was covered, it's you're not coming back from that. I like it when students prove me wrong, but they don't prove me wrong on this one. You're not coming back, which is why I should tighten this deadline. But I like the optics of, hey, look, I gave you a chance. I gave you 11 extra or 9 extra days. Is the course for fall students also who are currently? Is the course for fall 25 students also who are currently enrolled at UB? I do not understand that question, Edia. I don't really understand. I interpret that as, is this the way the course is going to be in the fall? This will be the same content. That's how I'll interpret the question. I think that's what you mean there. This is the same content that will be in fall 25, but there's a lot of stuff that has to get cut in the summer to fit it into a 6-week structure. So there will be different assessment, but yep. So there will be different assessment structure, but the content will be mostly the same. We have room for a little bit of a few kind of bonus topics. We call them application objective topics because they're worth a couple of application objectives. But most of the content, most of the slides you see here will be the same for the fall. If you're looking to get prepared for the fall, I would go to, well, you're already on the YouTube, but I would go to videos, and you can see all the 116 lectures. You can see the way the course is structured in a fall, spring semester. Actually, that's not super helpful because I didn't post my videos from last semester. But do I bother going in to this? If you are prepping for the fall, one, you can watch these lectures. That's perfect too. Two, if you go to the course website, actually let me show you here. If you scroll all the way to the bottom of the course website, there's a link to the website GitHub, which will take you directly to where I just was. And if you go to tags, I do tag each semester's version of the course. So if you go to S25, you can see exactly what the course website looked like for spring 25. If you download the source code and run the server, you can see the spring 25 version of the course. So you can see that syllabus, all the programming assignments, the grading structure, everything. It'll be similar. There's always small changes, but it'll be similar to what it's going to look like in the fall. The big difference is we don't have interviews in the summer. There's just no way to fit them in. You'll have interviews in the fall. There will be a different programming. The program test will be different. There will be lecture questions. Not too many differences, but a few pretty big differences. Okay, so that's the programming test, the deadlines, how you're earning your 8 application objectives for the programming tasks. I'll repeat it one more time. Just do the tasks as soon as you can, and you pretty much get 8 free AOs just for doing your work on time. And if I didn't use mastery-based learning, I said I wasn't going to take 50 minutes to read the syllabus, and it's 8:42 already. Jeez. If this weren't mastery-based learning, if this were just a percentage-based, homework is this percent of your grade, quizzes are this percent of your grade, if it was one of those grading structures, the expected deadline would be the only deadline. The only reason the final deadline exists is to soften the blow of the severity of the grading structure and the unforgivingness of the grading structure. That's why you have this 11-day deadline, is in case there is somebody out there who just one of the assignments just didn't hit them right, or maybe you got sick or something happened where you couldn't meet an expected deadline, you still have a chance to pass the class. That's why the final deadline exists. This is the only deadline that, in my eyes, is the real deadline. So if you just do your stuff on time, I'll throw you a B+. To get the last 4 application objectives, those come from the quizzes. So I said the midterm and the final exam are the same thing. They're both going to have 4 traces, 2 OOP and 2 data structures. And you need to complete 1 trace of each category to pass the class, to complete the learning objective. And if you're really paying attention, you might ask, actually, if you don't be paying attention too well. If you're paying attention at all, you should be wondering, well, if I complete 1 of each on the midterm exam, what's the point of going to the final? And my answer is there is none. If you complete at least 1 OOP trace and 1 data structures trace on the midterm exam, you don't have to go to the final at all. You're done. You already completed the learning objectives. There's nothing for you on the final, and you shouldn't be doing anything that day. Your semester ends as soon as you're done with task 8 at that point. So after the midterm grades come out, that's the first time where you can just be absolutely, completely done with the course. And I would like to see that. I would like to see you study for the quizzes, for the midterm, come to the midterm prepared, crush those traces on the midterm, get your learning objective, and not have to take the final, and have a lot less stress. Because going to that final exam with your whole semester on the line can be very stressful. I don't want to see you go through that. So pass them on the midterm and don't take the final. To encourage that, 4 traces on the midterm, each one you pass on the midterm is an application objective. So if you study for the midterm, which I'd say you should anyway, you should study for a midterm. It should go without saying. But I'm going to encourage you to study for the midterm and not rely on that final exam, because I don't want to see you going through that stress. I'm going to motivate you to go for the midterm by putting 4 application objectives on the line. So for each trace, so you need 1 trace to get the learning objective, but if you get both traces, like both OOP traces, you're going to get 2 application objectives. So there is still something on the line to get that second OOP and that second data structures trace. So there's, you don't just, I'll just do half the midterm and get my learning objectives and just cut loose. Do all 4, get 4 application objectives. That can make up, if for some reason you miss 2 of these deadlines, you can still make up for that on the midterm and still get your A with the 10. So that's the way the grading, and no application objectives for the final exam, just like there's no application objectives for the final deadlines. If you're relying on your last chance to pass the class, I'm not rewarding you with any application objectives for that. Okay, and that's how the course is graded. It does take a while, just because it's a different type of grading structure. It does take a while to cover it. I was hoping to not take that long, but it is what it is. Yeah, the first task. So task 1, it is unit testing. We're not going to talk about unit testing till next Tuesday, but we will talk about the Java basics today. So you will be able to get started with task 1 today with what we'll cover. But I'm about to go over my, let me do this stuff real quick. There's no textbook, palette links if you need them. Academic integrity, don't cheat. All academic integrity violations are an F in the course. I mentioned one of these. If you post your code publicly on Piazza, it's a pretty clear violation. You're sharing your code with the entire class, your solutions with the entire class. Pretty obvious academic integrity violation. Usually that one is an innocent mistake, but depending on the situation, if I think it was actually an accident, usually I'll just give students a warning on that one. So don't panic. Don't be afraid to make a Piazza post because you might accidentally fail the class. But please be careful. Don't post your solutions to the whole class. But I won't belabor academic integrity too much. The one big thing, obviously, is big these days. You all know this, I'm sure. But don't use that artificial intelligence to write your code. You have to actually write your code. I might challenge you if I look at your code and I suspect that you did not write that code. I'll call you in, I'll send you an email, call you in for a meeting, we'll go into a Zoom call, and I'll challenge you to explain your code. And if you can't convincingly explain your code to the point where I am convinced that you are the actual author of that code, it's going to be an academic integrity violation. And I don't even care what the reason is. If you can't explain your own code, you fail the course. It's an academic integrity violation. I might suspect that it's AI, but I don't have to know exactly what the reason is why you can't explain your code. If you can't explain your code, you didn't complete the learning objective for that task, and you're done. You got to be able to explain your code. Anyone who wrote their own code, this is no problem. It's nothing you don't have to think about. If I challenge you because whatever in your code I thought was suspicious, I call you into that meeting and you're like, oh yeah, this does this, like any person who wrote their code would be able to do, you're going to be fine. But if you didn't write your code, if you did something like this, or submitted work that it wasn't your own, that's, you're not going to be able to explain your code and you're going to fail the class. This is, I guess, more common in the fall and spring. But also, don't work with other students to write your code. This used to be the more common way of cheating. This used to be by far the most common way of cheating, is just working with another student on the coding tasks. And then by the time you both submit your assignments, your code looks almost identical. Even though you didn't share code with each other, if you're just working together, your code's going to end up looking extremely similar. That's going to show up on my similarity checks. This, you're not going to get a chance to explain your code. If your code looks very similar to the code of another student, that's an easy F in the course. Like, there's no excuse for that. There's no reason to have code that's super similar. I do err on the side of caution on this. Like, it has to be pretty obvious that you did either share code or work on the assignments together to be able to get this one. But this one, I'll just pull up you and your friend's code. I'll in a Zoom meeting, and I'll say, look at how similar it is. You didn't both write this independently. That's an F in the course. If you're not cheating, you don't have to worry about any of this stuff. It has to be a preponderance of evidence, to use a legal term, for me to go after you on one of these. It has to be pretty obvious to me that there was something fishy going on. And I won't go just read through all the rest of them, but you can. But those are the common ones. These are the three that 3 reasons why students fail most often. Okay. And this is where I'd be like, all right, see you Wednesday. But hey, all right, now it's Wednesday. We got to go right back into it. So after all the syllabus, by the way, this can collapse once you read all this and you actually have read the syllabus or heard me read it to you just now or whatever. These do collapse, and then when you refresh, when you go back to the page, they'll stay collapsed. So once you're done with the syllabus, you can collapse it and just unclapse it when you're ready to refer to it again. And then we're ready to get into content. So this week, Tuesday and Thursday, today and Thursday, is Intro to Java, just getting used to how Java rolls. The course is in Java, of course, but I just want to highlight some things with the schedule first. The first programming task will be listed under the lecture that covers the content for that task. So that's when the task is officially assigned. Now they're all live. You can read all 8 tasks right now. You could do all 8 tasks right now, which I'll recommend in a minute. You can see what the task is. You can submit it to AutoLab. You can get your feedback and everything. But it's listed on the lecture that covers the last content that you need for that. So unit testing, there are 3 methods that you have to write, and then you have to write unit tests for these 3 methods. We haven't talked about unit testing yet, but you can write the code for these methods based on what we're going to cover today and Thursday. So you can write the methods first and then the testing after. Throughout the semester, I'm going to recommend writing your tests first, but nobody does that anyway. But for this one especially, you can write your code first for these 3 methods. So you can get started today after today's lecture. And then the schedule, okay, this is when the content is covered on June 3rd. That means June 5th, 8 a.m. is that expected deadline for task 1, and then 11 days after, it's going to be the final deadline for task 1. So you can see all the deadlines, everything's scheduled out. You can see every single task all the way up to task 8. All of them are fully released, and the graders are fully live on AutoLab, and you should all have access to AutoLab right now. So, putting all this together, just one last thing before we get into actual content. Actually, 2 last things. I got a lot of stuff I gotta say. My recommended strat, if you want to speed run CSE116 this summer, you have all the programming tasks available to you right now, so you can get started on the programming tasks. You can submit them to AutoLab and everything, but you don't know the content. You don't know what you're supposed to do, how you're supposed to approach these, but you have all the lectures from last summer. So right now, today, this week, you can go through all of the lectures. You can go through each one. There's 2 of each. I'll explain the differences. That's the second thing I want to talk about before we get into content. But you can watch the lecture, either the 11 a.m. version or the 8 a.m. version. I don't label the 8 a.m. versions. I'll do the same thing this semester. Watch the lecture. Well, today you're just watching it live, presumably. I guess you could be watching the VOD. Well, you're watching it right now, regardless. And whenever right now is for you. And you can, right after this lecture, watch lecture 2, lecture 3, and by the time you watch lecture 3, you have everything you need for task 1. Do task 1. Once you're done with that, watch lecture 4, do task 2, watch lecture 5, do task 3, etc. Watch all the lectures and do the assignments. You have everything available to you right now. There's nothing stopping you from going through the entire course this week. This would be extremely difficult, but if you can absorb this content extremely fast, if you could watch the videos on ×2 speed and still absorb everything you need to absorb, and then go through the programming tasks, start crushing the programming tasks and not run into crazy bugs or anything, you could finish the course well, that's not entirely true. You can finish the programming tests this week and then sit around and wait till for June 24th for the midterm. Go to the midterm, get your one OOP and one data structures, at least one of the traces of each done, and you can be done with the course on June 24th would be the earliest. You can be done with the programming tests this week. That's my recommended strat if you're trying to speed run the summer, which even just regularly going through the summer is basically a speed run anyway. So that's my strat. Don't wait for the lectures. Don't sit around idle. If you're ever sitting around idle, ready to do the next thing, it's all available to you. I mean, I'll still live stream all the lectures again this semester, but you do have the videos if you do want to get ahead. I'm going to cover the same things in mostly the same ways with pretty much the same slides. It's all going to be pretty much the same, but I'll still live stream it just so I'm still delivering the course. I wouldn't want to not lecture the course. That'd be weird. I don't know. I can't do that. But you do have the option to look at the previous ones. So that's my recommended strat. Go through the course this week and just be done with it. Because the 2-day expected deadline, that deadline is pretty tight. It has to be because it's the summer. I gave my reasons for it, but it is still pretty damn tight. So if instead of giving yourself 2 days, you watch the first 3 lectures today and start working on programming test 1 and give yourself over a week to complete it, you're going to be in much better shape. You're going to be able to relax a lot more this summer. Okay, last thing, there's 2 lectures, the 8 a.m. lecture and the 11 a.m. lecture. It's 8 a.m., this will end at 10:30, and I'll try to watch the clock and end at 10:30, and 11 to 1:30. So 2 different lectures, and I will teach both of those lectures using different styles. I mentioned this in my intro email, but I didn't mention what those styles are. In the morning, in the 8 a.m. this lecture, I'm going to go through my slides and teach off of the slides. Pretty much exclusively. There are times where I'll jump to IntelliJ to do some examples, and times where I'll go to, including today, probably pretty much every lecture, there will be a time where I'll head over to the tracing tool and we'll go through a live trace, but the concepts will be covered in the slides. In the 11 a.m. lecture, I'm going to use a different style where I don't intend to open a single slide except for one exception when we get to the graphs lecture. This lecture right here, I pretty much have to do in slides. It's the only way I know how to cover that content, to cover it well anyway. And that one I'll do slides in both lectures. But other than that, I don't intend to go through any slides, or at least many slides, in the 11 a.m. I'll do everything through IntelliJ, which is the IDE that we'll use to write Java code. And there's a Piazza post on how to set up IntelliJ. I might not have time to do it in lecture, but if there is time on Thursday at the end of lecture, I'll go through a tutorial. But this is what we'll use to run Java code. I run this program. It says, hello, Java. And this is the first example we'll go through in the slides too. So in the 11 a.m., instead of going to the slides, I'll go right to IntelliJ and I'll teach through live coding. So whatever strategy you think whatever strategy will work best for you, you don't have to think, you know what works best for you. You can watch that lecture. You don't have to attend the lecture that you're registered for, so you can choose your lecture style that you want, or watch both of them. If you want to watch both and get both styles, or maybe watch both until you realize what structure works best for you, go for it. Those of you at UB who've taken this in the fall or spring and know of the other instructor, Paul, I'm basically doing my style, Jesse's style of lecturing at 8 a.m. and Paul's style at 11 a.m. Part of this is, well, I'm teaching the same lecture twice in a day. Might as well mix it up to give you 2 different strategies to diversify your options. But also I do it to reduce my insanity, because if I do the literal same thing twice, it's not too bad back-to-back with 50-minute lectures, but when it's back-to-back for 2.5 hours of doing the same exact thing twice, I will drive myself insane. So partly it's just for my own sanity, but I also enjoy that I can. Why did that open like that? Part of it so I can give you that variety as well. So if I click it here, it'll open the way I want it to. But if I click up there, it does not. Yo, what's up, Necro? Thank you for the kind words. Right. View. Presentation. Whew. All right. Let's start some content. All right, so these are the things we'll talk about today. Like I said, I might not have time for the whole IntelliJ tutorial, but the post on office hours and the post on Piazza and also office hours, if you're having trouble getting IntelliJ set up and installed, when you go to install IntelliJ, I always do recommend the IntelliJ Ultimate. I think it's, IntelliJ Ultimate. I recommend that. You can get it for free with your educational license, which you get for free by having a .edu email address. But the Community Edition does everything that you need for this course. The other one, jeez, I already forgot. But the Ultimate one, that has more features that you might find useful in the future. So I always recommend getting that set up while you're setting up IntelliJ for the first time anyway. But if you want to use Community, that's fine. For what it's worth, I'm going to use Community Edition in lecture, and you won't even notice the difference probably. I won't notice the difference because we won't use any of the more advanced features anyway. But I do use Ultimate on my laptop. Just on this device, I decided to only install Community, partly to make a point that Community is fine for the course. But for like side projects and other stuff, it can be nice to have the extra features. One of the nice extra features is being able to do syntax highlighting for different languages. So when you have projects that mix languages, it's nice to just do everything in one IDE instead of having IntelliJ just for Java. Which IntelliJ, it's an IDE, so a text editor that also runs your code and does syntax highlighting and all that stuff. That's tuned for Java. It's meant for Java programming. So right out of the box, it's ready to go for Java. At least for the most part. There's a few steps. That's what the Piazza post is for. And that's what I'll be using during lecture as well. Packages, types, and methods. Let's do it. So Tuesday, today, and Thursday, we're basically going over 115 in Java. We're going to cover most of the 115 topics, all of our basic topics, everything I listed on the syllabus where I said you should be familiar with all of these concepts. In a language, it might not be Python if you didn't take 115 at UB. Wherever you took your CS1 course, your Computer Science 1, whatever language, if it's C, C++, maybe it was Java even, you should understand those concepts. And then in these first two lectures, I'm going to cover the syntax, mostly the syntax of Java, with the assumption that you already understand the concepts that I'm covering. Now, a few things are different in Java, and I'll highlight those as we go, and I'll give more attention to those. But when it's just syntactical differences, like we use braces instead of indentation, that I'll just mention. There, I just mentioned that one. I'm done with that one now. And move on really quickly. But when it is a new concept, like strong typing that we'll talk about today, I'll spend a little more time on it. So let's do this. Let's roll into some content. 9:03. Let's do it. We have a little bit of slack on at the end of Thursday. I use that week 2 Friday as a catch-up day, so not concerned. But I do want to get caught up a bit. As we go through content, we have live chat here. Something didn't make sense. This is the reason why I'm still live streaming instead of just saying go watch the old videos and figure it out. It's so we can have interaction in chat, so please take advantage of that. If I say something that doesn't make sense, if you want me to explain something again, better, different, let me know. If just something doesn't hit you the right way, let me know in chat so I can personalize the experience to you, because that's the reason to still have lectures and not just point to videos, even though we can do that. We have the technology to do that these days. Live lecturing for interaction and questions. So please take advantage of that. But yeah, this is Hello World in Java. This is the simplest Java program possible. And it's still not that simple. It does nothing. It just prints hello Java to the screen. And it's still pretty complex. The only thing I could trim down from this is package week 1. We can omit the package and use the default package, which is something I will not show you. I will not do all semester. But you might have seen before if you've programmed in Java. It's not recommended. Please don't code like that. But it is technically optional to have a package declaration. Other than that, this is the bare minimum to just have a program that does a thing. So let's break this down. First, the package declaration. The package declaration, you can think of this as the directory structure. The package has to exactly be a one-to-one. Package has to match the directory where this code lives. Now, and Java will enforce that. So this code is in a directory named week 1 because it's in a package named week 1. So when you go to the examples repo, and one really nice thing about this, the reason Java enforces the packages, one reason why it enforces the packages like this, is it forces you to keep your code organized. And then when I show you examples in lecture, you can look at the package declaration. I won't always put the package declaration because after a few lectures you're going to be able to predict what the package is. It depends. If it's lecture 3, the package is going to be week 3 for the most part. But you look at the package, week 1. So that means this code, all the code is in the source directory, src, short for source code. And so all the code is in the repo. If you go to that GitHub repo at the top of the website, there's going to be a directory named source. You click on that. There's going to be a directory named week 1. You click on that. And then in that directory, there's going to be a file named helloworld.java. And that's where this code lives. So if you're ever trying to find a lecture example in this course, you can follow the combination of the package declaration, and the class name. I got a little ahead of my slides already on slide 2. That's going to tell you exactly where to find the example that's being shown on the current slide. So this is creating a class named Hello World, and the only thing we need to know about classes right now is that every piece of code you write in Java, with only 2 exceptions, package declarations and import statements, all of your code that actually does anything is going to be inside a class. So we need a class. We have to have a class to be able to start writing Java code. So already we have one requirement that increases our complexity of this program, which isn't a big deal because this is your second computer science course. We can handle more complexity. It's not a problem, but we do have to explain quite a bit of stuff on our first example here. So we're creating a class named Hello World, and then everything in the following braces is part of that class's definition. Now classes, as I mentioned already, classes have to match, the class name has to match the file name that defines that class, and each file defines one class in Java. So I created a file named helloworld.java. That file has to define a class named Hello World, and inside that class is all the code for that file. There are a few exceptions, not to get ahead of things, but there are things called interfaces and abstract classes as well. For now, I'm going to say it has to be a class, but yeah, it can be an interface. For those of you who know, if you know, you know, there are interfaces. Not everything has to be a class. But for now, until we talk about interfaces, everything has to be a class. I'll just say it that way. So this code can be found in source week 1 helloworld.java, and you can tell that just from looking at the code itself. So it's kind of a nice feature of Java, and it will enforce this. If I change this W to a lowercase w, Java's going to yell at me and say, hey, that doesn't match your file name. Either change your file name or change your class name so they match. Which is a nice thing, that it does force some organization. It is, I don't know, I enjoy it. That I know where to find anybody's code just by looking at the code itself. The code is self-descriptive in a way. And then our main method. So our first big it's not really our first big difference. We just covered 2 big differences. But one of our first big differences is I will not say the word function at all. When I said you need to be up to date on your 115 content, I mentioned function. I mean function, the concept of a function, but Java actually doesn't have functions, it has methods. So a method is what would be a function, but is defined inside of a class. And since in Java, all code needs to be defined inside of a class, we don't have any functions, they're all methods, or more accurately, inside of an object, but we haven't talked about objects yet. So every would-be function is actually a method in Java. So I'll say method, you'll hear me say method all semester. I'm going to say it probably every single lecture, I'll say method at least once. And I'll almost never say the word function except for like this slide. I'll say function a few times. But other than that, I really won't say function at all. So if... and I'll say that to be accurate. I want to be correct. I don't want to say the wrong thing in lecture. But if whenever I say method, you hear function and you just think of methods as functions, it's perfectly fine. Everything you've learned about functions is going to apply to methods, with one exception that we'll talk about next week when we talk about classes and objects. There is one small difference between functions and methods, but which is the reason why they actually have different names. There is a reason for it. But for now, if I say method and you hear function, that's perfectly fine. But I will be saying method. Everything you know about functions applies there. So a main method is a special method that is going to be the entry point for your program. When you run a program, so when I run this class, this Hello World class, what's actually happening is it's running the main method inside of that class. So this is the method that starts your program. You start at the first line of the main method, and then run all the lines of the main method. And once the main method ends, that's the end of your program. So this is where everything starts and ends, is the main method. Main method has a lot of keywords here. I skipped one of these keywords already, public. But all these keywords, all this stuff here, all of it's required to have a main method. So let's break these down one at a time. Throughout the semester, you're going to know all about public, static, void, class, I guess, too, package. You're going to know all about public, static, and void, primarily being the ones that I'm not going to talk about in detail today, but I'll give you the very brief overview of what each one of these mean right now. But when they are relevant in the course material, actually void will be relevant today. When they're more relevant to the course material, we're going to talk about them. The difference between static and non-static methods, that's a big topic that we will dive into. You will know all about it later. Just not today. We got enough stuff to talk about today. But let's talk about it briefly. Static means this method can be called without taking any extra steps. We'll learn later that those extra steps are creating an object of the type matching the class that it's in. We haven't talked about objects at all yet. So we really can't talk about static because we can't talk about what it means to be non-static. Very briefly, static basically makes a method behave like a function, so we don't have to think about that difference between methods and functions yet. So static just makes things simpler, so we don't have to think about topics that we haven't covered yet, and we can, if everything's static, then we can basically treat Java more like Python. It's going to feel more like 115 or any CS1 course for these first two lectures. So everything's going to be static for the first two lectures. Void means this method doesn't return anything. We'll talk about return values in a minute. Main, this is the name of the method, just like any other method in any other language, no matter what your CS1 language was. This is the name of the method. And for the main method, it has to be exactly named M-A-I-N, all lowercase letters. If this is a capital M, you don't have a main method anymore. So the main method has to be named main, and then it has to take an array of strings as an argument. This is another topic we'll talk about in a minute here. We will talk about this one today. But string array is the type of the parameter of the main method. We're actually not even going to dive into arrays. This is the syntax for creating an array, string array. And the main method has to take a string array as a parameter, or else, again, you don't have a main method. And finally, public, that I skipped over the first two times it came up, but because I wanted to talk about it here, this means that the code can be used from anywhere. So these are this is an access modifier. We're going to see two of these right away, and then one of them protected later on in the semester. Public means the code can be used anywhere. There's no restrictions on who can call these methods. And for a main method, it has to be public because somebody from outside of this class, IntelliJ's class loader, is going to be calling this method. So we need it to be public so it can have access to it, as opposed to private, which means they can only be accessed from within the class itself. So we'll see that later in the semester, the difference between public and private. But public means everybody can call these methods. Your classes, your top level classes, are always going to be public, or else what's the point of writing your class if nobody can access it except from within that class? So we'll have public, we won't have a private class here. And your main method it has to be public, static, void, it has to be named main, and it has to take a string array as an argument. The only thing that can change here is args. This is a variable name. This is a parameter name for your method. Args can be different. You can name it whatever you want, but by convention, we usually call this args for arguments. This is the command line arguments. We're not going to use those at all this semester. We're going to completely ignore them. But if you were using command line arguments, this is where they would go. So args, short for arguments, just makes sense. It's a sensible name for it, and it's what everybody calls it. There's no reason to break that convention, but it's the one thing that can change and still have a main method. But if any of these other 5 ingredients are not here, or exactly like this, then you don't have yourself a main method. And when you try to run this code, it's not going to run because you don't have a main method, and you need a main method as your entry point to the program. Okay, so that's Hello World. It takes like 10 minutes to go through Hello World, and that's assuming that you already know. Like, I don't have to say what a function or a parameter is, and explain the basics of programming. It still takes 10 minutes. So that's a lot. And this is exactly why we don't use Java in 1.15, at least anymore. We actually used to, and this was day 1, and it was painful. It was like half an hour to cover Hello World. As opposed to Python, print Hello Python. Done. This is how you print things to the screen. I didn't even started talking about the actual code that does stuff at all. I just talked about the boilerplate, structure of a Java program, and it takes that long. So this is why we don't use it in 1.15. Or if you don't want to memorize all this stuff, which I recommend not memorizing things if you don't have to an extent. I guess artificial intelligence is making that statement a bit different these days, but where it's getting overused. But as long as you know what this is and you can type this out, you can use IntelliJ's shortcut. Just type MAIN, just type main and hit enter, and IntelliJ will type out the public static void main string argument, string array args. It'll type out all that stuff for you. So you don't have to exactly memorize, like, wait, was it public void static or was it public static void? I don't remember. So you do have shortcuts. That does make this a little bit easier. Realistically, in 1.16, shouldn't really have to write any main methods, to be honest. All your programming assignments are going to be through unit tests, which we'll talk about next Tuesday. So finally, after all that, we can write some damn code. We want to print something to the screen. It's Java, so that can't be as simple as print hello Java. It has to be complicated. So system.out.println, and then a string. This is a method that takes a string as an argument. So we're going to give it this hello Java as a string, and then that's going to print that to the screen. Capital S on system, lowercase o on out, lowercase p on print, and ln, print ln. Ln short for line. This means there's going to be a trailing line break at the end of this. So this will behave the same way you would expect coming from Python. It's going to print the string and then a line break. And the next thing you print will be on the next line. Or if you don't want to type this out, I can't even remember the last time I printed this out. That's a little bit of a lie because I had to use a text editor during a lecture once. It's a long, boring story. But I had to use a text editor with no syntax highlighting or anything. It was just Notepad on a Windows machine. So I actually had to type this out last semester. But before that, I don't remember last time I typed it out, because IntelliJ, you type S out, and it's going to print all this stuff for you, just like the main method. So you create a class, you type main, enter, S out, enter, and IntelliJ's got our back. It's going to help us not have to write these long things anymore. I used to have to type system.out.println every time, and it sucked. We don't have to relive those days. And every statement in Java ends with a semicolon. I don't have much to say about this, just don't forget your semicolons. It's very hard to forget a semicolon. This, again, not to do the whole back in the day thing. I'll try to limit those. But back in my day, we had to actually remember our semicolons, and we would get crazy cryptic error messages, and it was because we missed one semicolon on line 53, and we had to actually manually find where that missing semicolon was, and it sucked. Those days are over. IntelliJ will just say, hey, you forgot your semicolon, maybe add your semicolon. It's right here. It'll underline it with a red squiggle and everything. Very, very hard to forget a semicolon. Like, you'll forget semicolons, but IntelliJ will just shout at you and say, right here, right here, you missed the semicolon. It's very hard to forget a semicolon and then not be able to figure out, oh my goodness, I missed the semicolon. Like, you're going to figure it out real quick, because IntelliJ is going to slap you across the face with it and say, on this line, you missed the semicolon. Okay. Let's keep chugging along. All right, variables and methods. So that was just hello world. We're done with the basic structure of a Java program. Let's start getting into some actual 115 content, not just printing to the screen. Let's cover 115 content in Java. So methods, creating methods, creating variables, storing variables and variables, values and variables. A lot of this I don't have too much to talk about, but the big thing that should jump out at you right now is strong typing. This is our first Java topic, our first actual new 116 concept that we have to talk about. So let's talk about it. Strong typing. Java is a strongly typed language. If you're coming from our 115 at UB, or from any intro course that used Python or JavaScript, goodness, I wish you the best of luck if you had a CS1 that was only JavaScript. Maybe. But anyway, if you're coming from 115 or any CS1 that used Python, you don't know what strong typing is yet, so let's talk about it. Strong typing means that whenever you declare a variable, you must specify the type of that variable. Oh, I like highlighting things on the slides, but it just advances my slide when I click on this program. The type of that variable. So you're specifying the type. So we don't just say num equals 2.4 like you would in Python, and then Python does all the typing behind the scenes, and you rarely think about the types of your variables or your values at any given time in Python, because Python just does dynamic typing, and if you mess up your types of a variable, it'll change the type of that variable, or rather a variable can just store a value of any type. You can mix types, you can do all kinds of crazy wacky stuff in Python. The only time you really think about this in Python is when you try to print a number to the screen. You try to say, like, print as a string x equals, and then plus x, and x is an int, and you get an error that says you can't do that, and you have to put your str and then in parentheses and manually convert your int into a string, or else you get an error when you try to print that int to the screen when you're concatenating it with a string, because you can't concatenate a string with an int, which, for what it's worth, that part, like I'm doing right here, this would be an error in Python. In Java, this is actually fine. This works just fine. But we do need to worry about our types much, 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 much more all the time in Java. So every single variable has to have a type. So I don't just create a variable num and assign a value 2.4. I have to specify the type of num when I declare the variable. And in Python, declaring a variable and reassigning a variable kind of get muddied. You don't really have to think about the difference between the two. In Java, we have to think about the difference. So here I'm declaring a variable. That means the first time I'm using, like I'm creating this new variable and using it for the very first time. When I declare a variable, I have to specify its type. So instead of saying I'm creating a variable named num and assigning it the value 2.4, I'm creating a variable instead in Java. I'm creating a variable named num of type double and assigning it the value 2.4. So num here can only ever store a double, which very briefly a double, if you haven't heard that term yet, a double is a floating point number, meaning a number that can have a decimal portion. We'll talk in the next example, we'll talk about a few different types, a few different numeric types and stuff. So this double, this variable is of type double, meaning it can only ever store a double. So num, I'm going to assign it the return value of multiplied by 2, which is a double. We haven't talked about that yet. But num can only ever be assigned a value that is a double. So any expression that resolves to a value of type double, we can assign it to num. But we cannot say, for example, num equals the string hello. This would be an error because I can't assign a variable of type double to a value of type string. I can't assign this value to this variable. It's going to be an error. Doesn't work. Doesn't work like that. But this num, this variable num, can only ever store a double. This is strong typing. And the implications of this, well, most of it I just said. The variables can only store values of their type. And the type can't change. I can't redeclare this. Like I can't say string num right here. I can't declare a variable name twice. That's going to be an error too. So once I say double num, I'm stuck with this num variable called num being of type double for its entire life. So I declared a variable called name num of type double, assigned it the value 2.4. That's how we read that line. Our next line, let's talk about methods. So we have a method call, and I don't have much to say about the methods themselves. I'll say it right here is the name of the method. Oh, that's a little misleading. Just let me explain, I guess. The name of the method, and then the parameter list, and then the body of the method is in braces. We use braces in Python. Indentation does not matter. You should use proper indentation just to make your code legible. But the indentation is not meaningful like it was in Python, where you had a colon and then everything indented at the same level was part of that method. And then you indented further if you had loops and conditionals, other code blocks. In Java, every code block is in braces. That's how we define when a code block starts and stops. Braces instead of indentation. So that's really all I have to say, translating from 115 to 116. The rest of the stuff I have to say about methods is the new Java specific stuff. And there's quite a bit to talk about here. So that's the stuff I want to talk about. So public and static, these we've seen on the main method. This is going to come up a lot. This is the first time I'm going to really highlight it. Public means the method can be called from anywhere in your entire project, from any of the files in your project, even if those files are in different packages. Anybody gets to call this method. Static means we can call the method without extra steps, those extra steps being creating an object, in this case an object of type variables functions, which wouldn't really make sense based on my naming. We don't have to do any of that. We just call this method through the class itself, not through objects of that type. We'll get to that later, like I said, but the last thing I want to say about these for now is when we're talking about this intro to Java and our unit testing on Tuesday, until next Thursday, everything, basically everything, there's one exception. Basically everything is going to be a public static method. Every single one of our methods will be public and static. This includes the 3 methods on your task 1 assignment. Those methods are all public and static. And that should just be assumed for now that everything's going to be public and static. And it shouldn't be a surprise. You're going to see public static, public static, public static. You're going to see that all over the place right now. They're all going to be, and once we have a non-static method for the first time, I'll highlight it and make a big deal and wave my arms and be like, oh, it's not static anymore. But until then, everything's public and static, and don't worry about it. Public static methods basically make these methods behave more like what you've seen in 115 in Python. They behave more like Python methods. The things we do want to highlight today and talk about a bit more extensively, a bit more in depth, is this right here, this type double hanging out right here. This, the type that's after the access modifiers and before the name of the method, this is the return type of the method. This must be here. Every method must have a return type, and this specifies the type of the value that's going to be returned by the method, which is the type of the value that this expression will resolve to when we call the method. So when I call multiply by 2 and give it an argument, I know that expression will resolve to a value of type double because that's the return type of the method. This return type is a very strict contract that you're signing in blood with Java. You are saying this, when you write this method, you say it has return type double, you are saying I will return a double. This method will always resolve to a value of type double 100% of the time. It is going to resolve to a double. And if Java detects that it isn't going to always result in a double, it's not going to run your code. It's going to say, hey, you got to fix your stuff. Because it always has to resolve to a double, because you're going to write other code. Like I have this variable num of type double that can only ever store a double, and I'm going to assign it the return value of this method. I need that guarantee on the other side. I need that guarantee that this will resolve to a double, because if it doesn't resolve to a double, say it resolves to a string, well, I can't assign that string to my double, so now I got issues here, and those issues are just going to compound and break the whole project. Your whole piece of software is just going to crash, and we don't want that. In Python, it'll just happily let your program crash. In Java, with strong typing, the types are going to be checked before your program runs to make sure that everything is legit before running your program. So what you end up with is Java being maybe a little more finicky than you're used to with if you're coming from Python again, but your program's going to crash a lot less often. You're going to have better code, stronger code with fewer bugs is what the end result of all the strong typing is going to be, which is the point of strong typing, which eventually you'll learn to love. Maybe not this semester, maybe this semester, but eventually you'll learn to love strong typing and something called the compiler. I'll talk about that briefly in a later lecture, but not today. We got time to go down that rabbit hole. Okay, and then parameters. We saw this already with the main method, but I didn't explain it because I want to explain it right here. Parameters in Python would just have names. This would just be multiply by 2 input. But since parameters are variables and Java is strongly typed, those variables need types, so every parameter also needs a type. So this multiply by 2 method takes a parameter of type double, so when I call it, I better give it an argument of type double, which I do. Num is of type double. So we've satisfied that part of the contract. We gave it a double, it takes a double, so everything's on the up and up there, everything's good. But I have to give it a double if I'm going to call this method, with one small exception. I could give this an int, and Java will automatically convert it to a double. But if I gave it a string, I'm going to get errors. It's not going to work. And then when I run my method, it runs all the code in the braces, and whatever I do in this method, I can write any code we know how to write. I'm declaring a new variable x of type double, assigning it input, which is a double, times 2, which is actually an int here, and then Java's going to convert that to a double, like a double times an int is allowed. The result is going to be a double. I'm going to store that double in this variable of type double x, and I'm going to return x. Normally I would just do this on one line, but I wanted to declare another variable so I could talk about it. And then I'm going to return x. We have the keyword return, and then some expression, and then this expression has to resolve to a type matching the return type of the method. If it doesn't, we're in trouble. And every path through the method has to result in a return statement that returns a value of type double in this case. We have to do that. It has to happen. Every path, now this method is just 2 lines and there's only one path through the method, but by different paths I mean if you have conditionals that and you're branching your code off into different directions, every path, every possible conditional has to result in returning a value of type double, or else code breaks, code's broken. Okay, so we call the method, all our method stuff happens, our types all match up because everything's a double in this case, in this example, except for the strings, but I never store those in variables. So all our typing is pretty simple in this method, in this example, because they're all doubles, but we'll talk about different types in like 1 minute. So this method takes a double, we give it a double, it returns a double, we store that in a variable of type double, so all our types are good, and then we're going to print new num plus num. Num is a double. I already mentioned this, but this is a little different than Python. Python, this gives you a type mismatch error, can't concatenate string and float. It would be in Python if we had the same code. In Java, this is the string concatenation operator that's part of the string that works with strings and any other type. And it will automatically convert this double into a string and then perform string concatenation on that. So this will automatically just concatenate to the string that we expect and print out new num 4.8 to the screen. Oh, I said 1 minute, I forgot about this method. Then I'm calling another method y with no arguments. It takes no parameters. And the reason I have this method, well, it's called y because why would this ever exist? Never write a method like this. This is a pointless method. But I'm just doing this to highlight the keyword void. So every single method must have a return type, but that return type doesn't have to be meaningful. Sometimes you want methods that don't return anything. So you give it a return type of void. We already saw this with the main method, but I didn't talk about it because I wanted to talk about it now. We have a return type of void, because when we talk about main methods, we didn't know about return types yet. So a return type of void means this method doesn't return any value at all. So since it returns void, I'm not going to assign its result to any variables because it doesn't have any result. There's nothing to store in a variable. And I don't have any return statements either. This method doesn't return anything. It's called strictly for its side effects, which means the method does something other than returning some meaningful value. So like if you're crunching numbers like multiply by 2, you're always calling that method to return the result of some mathematical function. I'll use that's a proper use of function, but not related to programming functions. That it's performing some mathematical, I'll use operation, some mathematical operation and then returning the result. But this method, the point of calling this method is for the side effect of printing something to the screen. So we can just have that as a return type void. Main methods, the purpose of the method isn't to return anything. The purpose of the method is to run your program. You're not returning anything to IntelliJ that called your program. Doesn't quite make sense. It does make sense in like C and C++ where you're returning a code, either an error code or a everything went great code as an int. But Java doesn't do that. We don't return ints from our main method. We just return nothing. For what it's worth, in void methods, you can still use the keyword return if you just want to shut down the method. If you have like an if some condition return, because you don't want to, you just want to stop the method if that condition is true, and then have some code after that that runs if the condition is false without having an else. You can do things like that. It's perfectly fine. Actually, that's a bad example. Usually you would do that in a loop. In a loop, you would have some condition that that returns would be an application of that. Okay. And then when you hit the end of the main method, program's over. And types. Summer goes quick, and we're already going through it. Lecture 1. All right. So Java strongly typed. We talk about that. But let's talk about how do we declare private class for same. So if you want a private class, you can put the word private right here, but that makes your code inaccessible. So private means that whatever you're declaring as private can only be accessed inside of that class. So if your class itself is private, you're not inside of a class yet, so that code is just inaccessible. So if you make a private class, you just can't do anything with that class. So there's no reason to ever do it here, but you can create what we call interclass. This is, by the way, this is outside the scope of the course. I'm just answering the question. I'll keep it brief when it's outside the scope of the course like this, but I do want to answer the question at least. What you can have is interclasses, so you can declare another class inside of a class, and sometimes you'll want to make those private. So then you can only use that class inside of its public class, and then that people from outside this class can use the methods of the public class, and those methods in the public class might use its inner private class, and that would be just inside these braces. You would say private class, whatever your class name is, and then some braces and all the stuff for that class, and then you can only access that class from inside its outer class. Not something that's useful in 116, but when you get into more advanced stuff, sometimes it's useful to organize your code like that. Alright, so we talked Java is strongly typed, but we only saw 2 types, double and string, so let's talk about 4 types. And these 4 types, we'll get a lot of mileage out of these 4 types. So let's learn about these 4 because we're going to see them all throughout the semester. We're going to be using these 4 types. Mostly double, string, and int. Every once in a while, Boolean's going to pop up, but let's talk about them. So double, we already saw this in the other example. A double is any numerical value that can have a decimal portion. That portion can be 0.0, that's fine, that's allowed, but it can have a decimal portion to it. And we call these floating point numbers. So there's actually another type called float, and double is a floating point number with double the precision of a float. A float is 32 bits, a double is 64 bits. So if you're wondering why it's called double, because that name doesn't really make sense, it's a floating point number with double the precision of a float, and then for some reason they just call them doubles, and I don't know, it stuck, and when I hear double I just think of, a floating point number these days. It's just programmed in my brain now. But double, when you first see it, doesn't really make sense. But that's why. And doubles can't always be represented exactly in the computer. This is foreshadow for next Tuesday. I'll have a lot to say about that. For now, just know that there's a reason we don't use doubles all the time. Int is something that is still useful, partly for this reason. For other reasons as well. We'll get into them. String, notice that this is a capital S, but a lowercase d, lowercase I, lowercase b, and these are highlighted in blue. This is highlighted in black. There's reasons for all those differences that we're not getting into today. The brief answer is these lowercase values are primitive values, and the string is a class value, or rather an object. Things we'll talk about later. Next Thursday. We should talk about those. This is a sequence of characters. It's what you would expect it to be, no matter what language you're coming from, except C, I guess, which doesn't have strings. But Python, C++, I almost said Java. If you did like AP Java in high school or something, you would it's what you would expect it to be. It's a sequence of characters, which is a different type. This is a primitive type char for a character. I don't really have anything else I want to say about strings. Behaves like you would expect. You can have str1 dot size dot split dot to uppercase. All the methods, whatever language you've used before, whatever methods you had available, they're probably available in Java as well. Okay, integers. These are numeric values that can only be whole numbers. So doubles, when we want our our floating point values when we want to have some trailing, some decimal portion. Integers when there is no decimal portion to be had. When we were restricted to just whole numbers. They can be positive or negative. I forgot to mention that with doubles. Doubles can be negative as well. And ints are always whole numbers, meaning even when you divide two ints, if we have 6 divided by 4, 6 as an int, if I don't put a decimal portion here, it's going to be treated as an int. Same with 4, there's no decimal portion. For example, if I put 6.0 divided by 4, this would be a completely different example. It would actually be an error in this case. But 6 divided by 4 is 2 integers. Whenever you divide 2 integers, the result must be an integer. So if I have 6 divided by 4, I'm not going to get 1.5 like I'd expect. I'm going to get 1. So this is something called integer division. It's one of the unique things we got to think about when we have integers. Otherwise, they're just whole numbers, and I would leave it at that. But integer division, 6 divided by 4 is going to result in the value 1 being stored in this int of num2. This is going to store the value 1 after this expression resolves, after this assignment. And the way an integer division works is it will divide normally, but only take the whole number portion of the division, the quotient, and it'll discard any remainder, which is effectively the floor of the result. So we get 1.5, and then take the floor of that to 1, and then that's what the division resolves to. And since it's floor, not rounding, even if we had 99 divided by 100, so we've got 0.99, we would think of that as pretty much 1. It's not going to round to 1, it's going to take the floor to 0. So just something to always keep in mind when we have integers, that they are always whole numbers, even when we have division and we wouldn't expect a whole number. Booleans, I don't have anything to really say about. They're Booleans, no matter what language you came from, they behave the same way. They're either true or false. For what it's worth, lowercase t, lowercase f. I don't have anything else to say. They're Booleans. Alright, and we're on to our first memory diagram. And just to make sure... And I think, so I want to do slides for the 8 a.m., but this is where I am going to deviate. When I have these memory diagrams in the slides, I am still going to go to the tracing tool to cover the memory diagrams, just because I think it's better. What's the words I'm trying to say? It's better for you. Is this exactly the way it is in the slides? Looks like it. Come on. Copy. Paste. There we go. And I have so much more room when I'm streaming this. I'll still zoom in a little bit, I think. When I have to put this up on a projector, I just lose so much room. But I think it's better doing the live tracing tool. I think it's better for you because this is what you'll use on the quizzes. When it's time for a quiz, you'll go into UB Power, you'll go to this memory diagram tool, and you'll have the code here exactly like this. And this is how you'll do the quiz, is through this tool. So if I teach you tracing through the slides and then expect you to do tracing in this tool, there's just a little bit of a disconnect there. It's hard for you to translate what you've seen in the slides to this tool. So just to make sure that's a one-to-one, I want to use the tracing tool for all of the traces instead of using my slides. Now I'll keep my memory diagrams in the slides if you find that helpful for reviewing and studying, because it has my commentary, my bullet points on every single slide that I'll talk about when I'm going through this. So if you find that helpful, I want to leave those in the slides, but I'll trace through them using the tracing tool, just like you're expected to do on the midterm and final. Okay, with that, let's do our first trace. So whenever we run a Java program, oh, and you saw that, by the way, I did that pretty quick, but oh, Alt-Tab, not, what am I doing? But I went to the repo, week 1, you can see hello world, you can see variables and functions. This is, for the most part, the code that we covered today. I actually didn't even realize this. The code is, I don't have the exact code that we covered in here. It's a little bit different, slightly different. But this is a combination of the two examples that we saw in the code, kind of intertwined together. So that's where you can find these examples in the repo, is right here. And then I just copied that code, pasted it into the tracing tool. And this is a good way for you to practice tracing it too as well. Just take any code, paste it in here, and go through the memory diagram. And if you come to office hours with a trace that you did on your own and say, hey, can you look this over and see if it's see if I'm on the right track, we'll always be happy to look through it. Me and the TAs will be happy to look through it and give you any feedback on it. Okay, so let's do our first trace. So in Java, the very first thing that happens is a main method call. When this program is ran, it runs the main method. So the very first thing in our memory diagram will always be a main method stack frame. Whenever a method is called, there's a corresponding stack frame. So we create a new stack frame, and the name of the stack frame is the name of the method call. And a reminder, for those of you who took 115 here, just another quick reminder, I will take this from the top. So assuming that you haven't seen any tracing before, because not all of you have taken 115, not all of you have seen this tracing tool before. So I'm going to start from scratch. So if you're like, yeah, I know we covered that in 115. Well, not everybody's taken 115, so I'm going to take it from complete zero. So we create a stack frame for the main method call. Even though that's different, right away it's different than what we did in 115 because Python didn't have main method stack frames. But I will explain like what a stack frame is. So a stack frame is an isolated environment for that method call. So inside these braces, while this main method is executing, it's executing inside of a stack frame, which is an isolated environment just for that method call. And when we have another method call, when we get to multiply by 2, we're going to put another stack frame on the stack for this method call, and that method call's stack frame is completely isolated from the other stack frame, meaning any variables in each stack frame cannot be accessed from the other stack frame, and only the stack frame on the top of the stack, which is the bottom of the stack visually, is the active stack frame. That's where your program is currently executing, and the variables in that stack frame are the only ones you can access at that time. So that's my very brief explanation of stack frames. And then we go through the method one at a time. Technically, args is in this stack frame, but we're never going to trace that in 116 because we're never going to use that variable. So that's one thing. There are a few things we do to try to keep these stack frames these stack traces a little simpler. And that's one of them. We're never going to put args in our main method. And then the first line of code that executes is printing I can print to the screen. Whenever something prints to the screen, we go to our IO section, add a line, and type out what was printed. So I can print is printed to the screen. We indicate that right here. And we run the next line of code, int num equals 4, our first variable declaration. So this is inside the main stack frame. We're declaring this variable. So inside the main stack frame, we have our name and value columns. So we have the name of the variable num that's being assigned the value 4. So we have the variable num with the value 4 in our main stack frame. That's part of our main method call. So that variable can only be accessed from within our main method stack frame. Now notice that even though I just made a big deal about Java being strongly typed, we do not put the types in our memory diagrams at all. We'll never put a type. This num is never indicated as an int at all, for reasons, partly because it doesn't affect the memory diagrams at all, but also partly because you can always infer the type. You can look at the value and see that, oh, I wrote 4, not 4.0. That's my way of saying that's an int. So we really don't need to. It's not helpful, and it's just not helpful to track the types in our traces. In our code, absolutely. In our traces, not so much. Then we're declaring another variable, num2. Not like that. New variable, num2, with the value 2.4. Another variable str1, with the value a string. And notice quotes indicating that it is a string. So if this had the value like 4, I'm putting quotes here. That's my way of knowing that that's a string instead of the instead of an int 4. When we print to the screen, it's always a string. We don't put our quotes when we print to the screen. That's not a typo. Quotes here when it's a value of a variable. No quotes when it's printed to the screen. Int num3. So I have another variable, num3. And that's going to have the value of 6 divided by 4 as integer division. My way of reminding y'all that it's integer division, and this is the value 1 is going to be stored in num3. And a Boolean bool, storing the value true. True without quotes, I know that's a Boolean. So we can infer this is int, double, string, int, Boolean. So we can infer the types of all 4 of the types that we've seen so far, just by looking at how their values look in the stack. And we're going to print I am num3 colon space and then the value for num3. And whenever we have a variable like this where we need to look up its value, we're going to do exactly what the computer does when it executes our code. We're going to look at num3, and we have to resolve this expression that is a variable to a value. We're going to go to our stack, look at the name, find num3, and then look at the value that's next to it. It's 1. So we put 1 right here. That's how we're going to resolve variables. That is how the computer resolves variables. And when you're doing a trace like this, what you're doing is you are being Java and running this code, and that's exactly what Java is going to do. What we're not going to do is look back at our code and re-evaluate what num3 should be. In this one, it's not too hard. It's one integer division. You have to remember about integer division twice when you're doing this trace if you're doing it that way, instead of once if you do it the I'll say proper way. But when things get more complicated, if this is the result of a method call of a variable, like you might be tracing through quite a bit of code and redoing a lot of work to figure out the value when you could just look at the stack and figure out what the value is. Can we ask questions on task 1 in lecture? Yeah, I won't always, like I might give you more brief answers depending on what the question is. But yeah, I'll be happy to answer task questions in lecture. If it's too complicated of a question and it's going to get lecture 2 off track, I might just say ask on Piazza or office hours. But I'll at least give you a brief answer in most cases. But again, it depends on the question. If it's a quick question like when's test, actually I wouldn't answer when task 1 is due because I won't remember always off the top of my head. Write a 6/4 print 1 instead of 1.5. It's integer division. So since 6 and 4 are both integers and we're storing the result in an integer, actually storing the result doesn't even matter. Since 6 and 4 are both integers, we get integer division here. And integer division must result in an integer, and integers must be whole numbers. So we effectively get the floor of the quotient, which is 1. So the 0.5 gets completely erased in this situation. And we just get the value 1 instead of 1.5. So that's my way of introducing integer division. Let's get this one in there. All right, and then we have, oh, we're actually looking good on time too. And then we have our next method call, multiply by 2. What if there's an integer over double? So if this is 4.0, now I have an integer divided by a double. Now I actually get an error. This resolves to 1.5 as a double, and then I get a type error because I'm trying to store a double in a variable of type int, and it's going to say, I'm going to get an error that says can't do that. But I would avoid integer division this way. So if I change this to double, then num3 would be 1.5 in that situation. So if you want to avoid integer division, just make sure either your numerator or your denominator, or both, is a double. If one of them is a double, then you will avoid integer division and get the decimal portion. So it all depends on whether you want integer division or you don't want integer division. If you don't want integer division, which in most cases you don't, make sure numerator or denominator is a double, and then you're going to avoid your integer division. And that comes up, and the task 1 is designed to exploit a few of these things when you're no, that's doubles though. Hold on, just yeah, those are doubles anyway. No, I should make this an array list of integers. This one's meant to expose that, but now that I think about it, I think I missed the mark on that one. But anyway, usually we want to avoid integer division. I'll have to change that for next time. Usually we want to avoid integer division, but sometimes we want integer division. For example, if the result of the division is supposed to be used as an index for an array, or an array list, as we'll see next lecture, then we actually do want integer division. So there are situations where we'll want integer division. So you can mix them. You can do a double, like I could do 6.4 divided by 4. Like this is completely valid. The reason I said it wouldn't work before is because I had my variable of type int. But since this is not integer division, the result of this division is going to be a floating point value that will have the decimal portion. So it will not be a whole number, which means I can't store it in num3 because num3 is of type int. That was where the issue is going to be. But the division is perfectly fine here. The division just goes through like just as you would want it to happen. But once we try to store the result in an int, then we have trouble. So if we're storing in an int, we better make sure we have integer division here. Okay, so let's get to our method call, multiply by 2. If you didn't take 115 here, your first method call, actually I guess we have a stack frame already, but our first method call at least, we're going to create a new stack frame. Every single method call has a corresponding stack frame. That stack frame is created when the method is called, and it is destroyed when the method ends. So let's create our stack frame, just like the main stack frame was called main. We're going to call this the name of the method, multiplied by 2. And then the first thing we're going to put in our stack frame are all the parameters, which just one in this case, assigned to the values of the arguments. So we're going to have a parameter input assigned the value num2. I have to resolve num2 to a value. This is in the main stack frame. I'm resolving num2. So I look in the main stack frame for num2 and I find 2.4. I strongly recommend, I feel like I never recommend anything. I always strongly recommend everything. So I'll just regular recommend this one because there's things later where I really need to emphasize. But I recommend going to the stack frame, going to the main stack frame and looking up the value and not looking at the code. In this case, it would be the same thing. You're just getting 2.4 because it was just assigned a value. But if you get in the habit of looking at the stack frame for the value, you're going to avoid some simple mistakes that can cause you to fail some quizzes. Like, for example, you see, oh, num2 is equals 2.4, but you missed a reassignment somewhere in here. If somewhere in here was num2 equals some other value, and you have 2.4, you're going to miss the reassignment. But if you look at the stack frame, you're never going to miss those reassignments. You're never going to make those little mistakes. So it's just something that makes your work a little more bulletproof. So num2 was 2.4. So, and that was assigned to the parameter input. So input is 2.4. It's the second time I did comma instead of decimal. So now we're inside this stack frame. So now our code is currently executing inside this method call. This method call is completely isolated from the main method. So when I'm in this method, I cannot access any of these variables in the main stack frame. And one benefit to this is, which might not seem like a benefit right now, but one benefit of this is that we can reuse variable names. So if I want to use num, num2, str1, num3, or bool, I can use any of those variable names inside this method. The reason that's important to you, whether you know it, whether you want to think about it or not, is when you're calling other methods. Like I'm calling print line, and print line takes a parameter. I don't have to care what that parameter is called. If stack frames were not isolated, every time I call a method like this, I have to worry about, okay, what does print line call this parameter that I'm giving it a string as an argument? It has to be stored in a parameter. What's that called? Because now I'm not allowed to use that variable name anymore. Because I'm calling print line, I have a variable name that's just crossed off my list that I can't use. I don't want to live in a world like that. I don't know, maybe you do. I don't want to. So the fact that stack frames are completely isolated environments means that I don't have to give a damn what print line calls that parameter. And same thing when I call multiply by 2, I don't have to give a damn what I call this here. When I write this method, I don't have to worry about any naming conflicts with any of my variable names, either parameters or local variables. I don't have to care. Like I'm using x. X is probably used all over the place. In the math library, x is used extensively. I don't have to worry about any naming collisions there. So there's one strong benefit to having these stack frames completely isolated. And can you put an OR statement in an assert equals? Yes, it's, oh, and you remember now. For anybody else reading that, it's the OR expression is 2 pipes. It's the shift and the key above enter. 2 pipe characters is OR in Java. And for what it's worth, and is 2 ampersands. So if I want to do like true or false, which would just be true in this case, this is true or false is a Boolean expression containing those 2 values, or ORing those 2 values. Doing that in an assert, oh, but the question was assert equals. I see you got the answer, but I just want to answer it for anybody else looking at it. Doing that in an assert equals doesn't really help. But doing that in an assert true is helpful. Assert true, you just write any Boolean expression that you want. You can use all your ands and ors and everything else. So assuming you're working on the third question, the best key, and you're working on that cat dog, I think that was the example I gave. Yeah, cat or dog. You can't really use an assert equals with that one. You want to use an assert true and write your own Boolean expression using an or. Will you recommend to learn the syntax for someone who is not able to understand the code? Will you recommend to learn the syntax? I do recommend that you learn the syntax. I'm trying to understand what you mean by the question, though. If you're having trouble understanding the code, I would recommend learning the syntax one piece at a time first. So if that's what you mean. So learning like what exactly this line means, and then start piecing together one piece of syntax at a time, and then start putting it together to learn the entire program. That's what I assume you're asking. If not, feel free to ask again. Okay, so we have input, and then just like when we started the main method, we have the, actually a little different because we have a parameter. But once we have the parameter on the stack, just one parameter in this case, we're ready to execute the method. So we have x, we're declaring a variable x. Oops, I actually missed a step already. I always forget this step. Those of you who've seen any of my lectures before, you know I always miss this one. But multiply by 2, I have a method call, and the result is being stored in num2. So we're going to add our return arrow. We click this return to variable, and then click on the variable we're returning to, which is num2. And we have our return arrow, which is a reminder to us of saying where the return value is going to go. So the return value, once this method returns something, it's going to go into num2. And I'm going to use that arrow. I don't have to think about looking back at the code again. I'm just going to follow the arrow when it's time to return. And then I'm going to create a variable. I'm declaring x as a local variable inside this stack frame. So I'm going to create x inside the multiply by 2 stack frame, and it's going to get the value input times 2. And notice I have a double here, and I'm multiplying it by 2. I didn't put any decimal portion, so this is an int. So I have a double times an int. The result will always be a double in that case. When I mix in the types, it'll always get switched to a double. The result will be a double. So I have a double, not that it super matters in this point, but just to keep track of our types. So input is 2.4 times 2 is going to be 4.8, is going to be stored in x. And then return x, x resolves to 4.8. So this method is going to return x. When we return, there's a few things that happen. So one, the stack frame ends. When a stack frame ends, it is removed from memory entirely. It is deleted from memory. So when we end this stack frame, when this method call ends and returns, there is no memory in the computer of that stack frame ever existing. For our purposes, we're going to cross out the stack frame to indicate that it was deleted. But when we're done with our stack trace, when we're done with our memory trace, we want a full history of everything that happened when that program ran. So even though this isn't in memory, we still want it to exist in our trace so we can know that that did happen in the past, even though it's not in memory anymore. So crossing it out means it was deleted, but we don't want to physically erase it from our trace because, well, I'll just wait till we get there. And then when we update a variable's value, we don't just type in 4.8 right here. We're going to use this plus sign to update the variable. That's going to cross out the old value, and we're going to write in the new value. And to do that, I just followed my return arrow. You can also look, okay, multiply by 2. We were right here. We returned to num2, but the return arrow helps us know exactly what happened and gives us more of the history when we're done. Why isn't the first stack frame the variable input? It is. Wait, in multiply by 2 in this stack frame, the first variable was input. So we always start with the parameters. Why is in the first stack frame the variable input? Or do you mean the main stack frame? A few ways I could interpret that. We could have args. Oh, I guess I answered it. We could have args. Technically, args is the first thing in the main method, but we don't trace that just because we'll never use it in 116. It would just be extra clutter in every single stack trace that we do. But technically, args is the first thing in the main stack frame, like in reality, in the actual program execution in the computer. So we have multiply by 2. We're done with that line, so on to the next one. Print line. New num2. And then the value of num2, I'm going to look that up in my stack, 4.8, because now it is pretty tough if you look through the code. You might find 2.4 and put 2.4 here by accident. You're under the pressure of an exam. You just might make a little mistake like that. You're not going to see that there was this reassignment here. You might miss that. If you do see the reassignment, now you have to go through the method call again in 2.4. I mean, it's not too complicated for this example, admittedly, but it will get more complicated. None of that. I'm not doing any of that. I'm going to look. I already did all that work. I'm not going to redo all that work. I'm We're going to look at num2. It's 4.8. 4.8. Done. Minimal thinking. Why I put input like a variable name and not like num2 again? Yeah, because it's a parameter of the multiply by 2 method. Yep. And then it gets the value. I guess this is a bit of a nuanced point. So we're passing num2, but we can't pass a variable to a method. That's just not something that we do. What we have to do is resolve the variable to a value. In that case, num2 was still 2.4 at the time. We resolved this expression, which is just the variable num2. It resolved to 2.4, the value, as a double, and then that double 2.4 was passed to the method, and 2.4 was assigned to input. So input got the value 2.4, not the value num2. That just doesn't make sense to have a variable assigned another variable. This variable was assigned the value that was stored in another variable. So new num2 4.8, and then y of 2, our last stack frame. So we got another stack frame for the method y. Oh, there's a happy little accident. Full screen's nice. Val is our parameter, and it gets assigned the value 2. And we execute the code in val, which prints I return nothing to the screen. And then returns. We hit the end of the method. We didn't have any return statements. We hit a return statement here, which shut down the whole method, just ended everything. Here we hit the closing brace, which also shuts down the method. This is a return type void. We don't return anything. We're just crossing it out. We have no return arrow. It doesn't return anything. It doesn't return anything to anything. It just shuts down entirely. And then we hit the end of the main stack frame. So the main stack frame is removed from memory and the program ends. Once the main stack frame is over, whole program is over. Everything's done. And this is why we cross out our stack frames instead of actually erasing them. Even though they are actually erased from memory, after a program ends, stack memory and heap, for what it's worth, when we get there, stack memory, the whole stack is filled with stack frames that have been erased. So the stack is actually empty. At the end of every single program, the stack is empty, completely empty. So if we actually erased our stack frames, every single trace that you submit would just be empty. You'd have the I/O lines, and at that point, we could just avoid all the tracing entirely and just say what is printed to the screen when this program executes. That's all we'd be asking at that point, which is problematic for a lot of reasons, not the least of which is if this says 1.5 and 2.4, well, that's a fail, like easily. Like you printed the wrong thing, and that's all we're assessing. That's it. But with stack traces, if you have all the right logic here and you typed the wrong things over here, we can say, oh, they clearly know what they're doing. They just made a math error. Maybe you have 4.4 instead of 4.8. That's perfectly fine. If you have all of this, but 4.4 here and 4.4 here, I can isolate the mistake to this multiplication, and I don't care if you messed up the multiplication. I just don't care at all. It's not a grade school math class where I'm trying to teach you how to multiply something by 2. I know you know how to multiply by 2, and I know you made a simple mistake that has nothing to do with CSE116 learning objectives, which is part of the nice side of the learning objective grading, is if it's not related to one of the learning objectives, if it's not related to classes, inheritance, polymorphism, linked list, trees, or graphs, I don't care. Like, you can make a lot of mistakes that are not related to those things, and I'm still going to pass you as long as you demonstrate proficiency in those 6 topics. So making math errors, but I see that you traced through the code correctly, yeah, I don't care. And this whole trace doesn't have anything to do with any of those learning objectives. So nothing here would, oh, that's a bad way of saying it, but nothing here is assessing any of the learning objectives of the course because we're still doing 115 review, but in Java, in the 116 language. So you can make a lot of mistakes on something like this. and still be fine. But you can't make too many mistakes. So like when we're assessing classes, inheritance, and polymorphism, if you make a lot of little mistakes in all of the other things with your variables, with your methods, with your stack frames, and all that stuff, if you make so many mistakes that we can't tell if you understand classes, inheritance, and polymorphism, those little mistakes could add up and cloud all the evidence that you do understand the core concept, that the learning objective that we are assessing. So little mistakes, as long as we can still see through them enough and there's enough evidence that you did complete the learning objective, it's still a pass. But if there's so many little mistakes that we can't tell if you understand classes, inheritance, polymorphism, linked lists, and trees, excluding graphs in that list because I wasn't talking about the course in general, just tracing, then it's still a fail, even if you do actually understand that concept. If you made so many little mistakes that we can't tell, that we can't distinguish, determine it based on the evidence you gave us through your submission, then it still has to be a fail. So little mistakes are fine. Too many of them can still result in a fail for that reason. F11 is my magic key. My laptop is a Mac, so I'm not used to having function keys again. It's kind of nice. Actually, I do have function keys on the Mac, but I don't know. It's complicated. How exactly do our quiz midterms conducted? At the start, so quizzes and midterms, that's the one thing you do have to take at your scheduled lecture time. Those of you who are here live, that's probably not a big deal for you. But some students are in different time zones. If they're across the country where this is 2 a.m. for them, it's a little less convenient, and they do have to suck it up for at least the midterm, and then they'll crush the midterm hopefully and don't have to take the final. But the way it'll work is at the start time of lecture, I'll send an email with the links to the quizzes. You'll click the link, it'll take you to the tracing tool like this with the code for that trace. So I'll send you 4 links, one for each of the traces, and then you go through the traces and do the traces. There'll be do I have one set up? That's sad. I have not seen that error page before. That's funny. Let's go to an old one. Java Basics. Well. Oh, here it is. You'll get this. Yes, I want to start. You'll get the trace, and there will be a submit button. You'll review. That's your submission. When you're ready, you'll submit, and then it gets into our grading queue after that. Then we'll be grading it. So you'll have the same exact interface that we just saw, except not hiding the menu here. You'll have your code, and you'll go through the trace just like I just did, and then submit it. So you'll have 4 links that'll take you to 4 of these that you'll complete, before the end of the time. All right, and that's it. We actually got through lecture. Oh, that's why we're so good on time. Oh no. It's because we have a whole nother set of slides. I'll be back in 1 second, and then we'll talk about loops and And that's why we were doing so good on time. Are you going to show us how to start a new project in IntelliJ, or will we need to watch the 11 a.m.? I guess I do have to do that in the 11 a.m. lecture. Showing how to set up IntelliJ, because I'll be in IntelliJ. It'll be easy to just cover it right there. So why, like, it shows. So we only have 5 minutes, but I'll at least get this started. 1, 2. We do have the Java examples. We do have some flex time, like I said, on Thursday, but I was going at a different pace because I forgot I have a whole nother set of slides for today. So it's not a disaster. I mean, I wouldn't have, even if I went much faster than I did, I couldn't have gone much faster, but we still wouldn't have gotten very far in this set of slides. So it's not the worst thing, but it was a little whoopsie. We will get on track. We will be on track by Thursday. We're not actually behind. But let's at least talk a little bit about this as much as we can in 5 minutes. To set up IntelliJ, there is a Piazza post on it and office hours, so I probably will end up mentioning it in the 11 a.m. But hopefully I'll find time on Thursday in this 8 a.m. lecture as well. I should be able to find time, even though we have to catch up on this set of slides. We should still have time at the end there to get through it, to get a good IntelliJ example at the end. So you have a few options to do to get that content. So conditionals in Java, is it even worth it with 4 minutes? I mean, I'll at least get through the explanation of the code, but and we'll get up to the point where we start tracing this, and I won't have time to actually do the trace. So conditionals in Java, your if, else if, and else, it all behaves just like it does in any other language, Python, etc. Again, the big difference between Python and Java is braces. Oops, I'm not even pointing at the conditional. Braces instead of colon and indentation. And that's it. It's the only real difference I have. This is, combining this with methods, this is where we get to every outcome, every path through your code has to result in returning a value of the return type. So this method that returns a string, no matter what condition I go through, it has to result in returning a string. Now what you can do is return after all the conditionals and make sure you return that way. Or here I'm returning within my conditional, so I have to make sure every single path results in returning a value of type string. And importantly, if I don't have an else statement, Java's going to say, well, what happens if all of these conditions are false and you hit the else, you're not returning a string. So I would have issues there. But since I have an else and every single condition results in returning a string, I'm good on that front. Else if instead of elif. I forgot about that. I always forget about that in Python. Python shortens else if to elif, which I think is weird. Python is usually more verbose and flows more like English sentences, except for else if. They just randomly erase 3 characters, the SE space. They just delete those for some reason. But elif in Python is still else if. It's just short for else if. Oh, and it is. I only have 1 slide on that. So let's just walk through what the code does. There's no way we're getting through the memory diagram, so I don't even want to start it. But what we expect this to do is we're calling the method with 98. We're going to use integer division here, so we have 98 divided by 10 is going to be 9, not 9.8, because of integer division. It's an int divided by an int, and then we're going to store it in this int, so luckily it is integer division. And then if 10's greater than or equal to 9, that's true, so we're going to return A, and then print A to the screen. Then we're going to call this with 75. tens is going to be 7. This is false, so we go to the else if. This is false, so we go to the else if. This is true, so we create a new variable, stores C, and I'm only doing this because I have a talking point in the trace that I want to mention that creating this variable will help me be able to talk about. And then return C, and then we call it again with 30. Tens is 3, false, 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 false. Go to the else, return F, and then print F to the screen. So that's what the code is expected to do. And then next time we'll go through the whole trace of how it actually does that, why it does that, etc. Even these slides are out of date. This is the old style of the tracing tool. All right. But it's at 1:30. I do want to respect the ending times at least. I like starting right on time and ending right on time. So that's the end of the lecture. I'll be doing, if you want another lecture, I'll be doing the 11. If you want to see the other style where I won't open the slides, I'll do live coding. But yeah, and Thursday we'll pick up the slides here. Again, I'm not concerned. We'll be able to fill everything in. These set of slides is about a lecture each. So this is 1 lecture, 2 lectures. Each lecture in the summer is the length of about 3 lectures. So then we'll have a fewer Java examples where I'll go into IntelliJ and do some live coding with y'all. And we're not going to be behind on content at all. All right. Yeah. You too, Tassim. Everyone have a great rest of your day. And I'll see y'all Thursday.